heat the house using this hot water. You can see these black pipes coming down through here. This is the hot water from the boiler. There's a fan coil in here, essentially a radiator. Hot water going through it.
Yeah.
You blow air across it, that heats up the air. Okay. It
Question?
also heats the domestic hot water. That's the tank in the corner. So I've got a tank full of domestic water, the stuff I'm going to take a shower in, and there's a coil in there with the hot water in it, and it transfers the heat to my domestic.
Why use extra circle between boiler and tank and this for the heat exchange?
Why not use the
Direct heating, yeah.
Okay, so if I were to, you hear of instantaneous hot water heaters, they bring the domestic water through the boiler. Well, what happens in a kettle when you heat water? You get the calcification in the bottom. The same thing happens in those. When we put this intermediary hydronic loop between the very hot surface of the flame and the domestic water that has all the minerals in it, I don't get the calcification at either end.
Okay.
At this end, the water that's in that loop is closed. It's in that loop.
And
A
it's
little
very
bit
clean water, yeah?
of minerals come out of it, and then they're done. That's all the minerals that there were. At this end, you've got hot water on one side of the coil and water on the other. You don't have that really hot surface for the calcification. So therefore, the energy efficiency of the system remains high. Whereas if you put on demand hot water heaters in, you're into a cycle of running chemicals through it to clean out the calcium over and over again. And up at my camp in the summer, it only went for 7 years, and then the chemicals ate the heat exchanger in the...
Normally once a year I have experience with this.
Yeah, so it's better to have a hydronic cycle.
What are these? They're everywhere.
Yeah, those are all our instruments. So there's 300 data acquisition points in the house, and that's how we measure the performance of everything. So these are the temperature of the fluid going to and from that coil. There's also, these are airflow sensors here. So the amount of air that's going through the heat recovery ventilator. I'm also measuring, you can see the little blue drip on there, that's the relative humidity and temperature. This is a flow meter here. So everything that moves in this house that has anything to do with energy, it's measured. There are local boxes, you see the gray ones there, there's 8 of those in the house. That's where all the information first goes. One of them has brains, it serves that information and then it sends it up to the server upstairs.
So you are tied to the grid.
We are tied to the grid, yes. So the photovoltaics is a grid-tied system, and it's a RESOP. It predates FIT in that the 4 kilowatts of photovoltaics on house A is connected to the grid. But really what's happening, the energy goes out into the grid through one meter and comes back through the other meter.
So, sir?
Yeah.
I saw that you have a collector plate system. I was wondering if there's any solar absorption cooling system in the house or any chemical.
Yes, we have in the house next door, we have an absorption chiller that we can use either waste heat from the cogen, so we're burning gas in a generator, use the waste heat to heat the house, or we can use that waste heat through the absorption chiller and it uses that heat to provide chilling. That is the one technology here that hasn't really worked out very well.
Yeah.
Its efficiency has been very poor, and we've really actually had a hard time getting it to work at all.
That's very difficult to start it in a normal mode, and then condition is changing, you have to adjust this machine again.
Yeah.
And all
So
the time.
so we could use solar energy on that to drive that. But so this is kind of what I would call the holy grail that certainly the solar thermal industry has been looking for, is an effective way to use solar thermal collectors to drive air conditioning. Basically what it's come down to now is the other system that's in this house is an air source heat pump. So right now it's capable of taking the heat from the air outdoors and putting it inside the house. You say, well, that sounds pretty incredible, but you've got a fridge at home. It takes the heat from inside of the fridge and puts it outside. And in the freezer compartment, that's where it actually extracts the heat from. It actually, it can go down to 0 because it can freeze water. Yeah. Well, this heat pump is good enough that it can go to -25. It can still extract heat. from minus 25 degree air and delivers it inside of the house. That's an electrical, so conversely, it's an air conditioner. It can take the heat from the inside of the house, put it outside, it's using electricity. I put in photovoltaics, I've got a solar powered air conditioning system. So from practical point of view, it would seem, I think the timer has basically run out on solar thermal driving air conditioning. Photovoltaics is now so affordable that that is solar powered air conditioning. Photovoltaics connected to the grid and an air source heat pump that is your air conditioner in the summertime.
And what is the COP during the minus 20, minus 25 on this air
At
system?
minus 25, that's where it approaches 1.
1.
The COP over the entire heating season is 3, and of course it actually runs up to 3.75. But there aren't really that many. I mean, we remember them, but there really are not that many minus 20, 25 degree nights.
Yeah.
Most of them are
Minus 10, minus 15,
where
yeah.
the COP is over 2, between
Wow.
2 and 3.
Oh, that's perfect, yeah.
So that is really where solar air conditioning has come in, is that it's photovoltaics. The cost of photovoltaics has come down so much. You now have this very high grade energy source, electricity. And remember at the beginning I was talking about the load being concurrent with the resource. When we get connected to the grid, basically the grid acts as our storage. Right? I said my house nets out 0. Without the grid, I couldn't do it. In the summertime, I produce a huge surplus of energy. I put it on the grid. And in the wintertime, I'm drawing it back out of the grid. Now, could every house in Ontario do that? No, because you'd have this huge surplus. But we are so far away from that happening that hopefully within your careers, we'll start to deal with a constrained grid, a grid that just can't absorb any more renewable energy. Right now, we kind of say we have one, but it's more of a political or business decision that we have a constrained grid than actually a truly technically constrained grid, in that we're generating too much power in the summertime. We don't know what to do with it all. Because luckily, a good part of the load, air conditioning, is concurrent with the resource.